Hi, I want to talk to you about the discriminant in this video. Okay, this is a separate video just about part of the quadratic formula called the discriminant. Okay, well this is the quadratic formula of course, but what's the critical bit? Okay, this is the critical bit there, because I'm not going to use this anymore, I'm just going to highlight that. That's the critical bit, the b squared minus 4ac. Okay, so just go write that in, b squared and then subtract 4ac. That is the critical bit. Why is that the critical bit? Okay, well, let me just give you a simple example. Okay, so let's have a look at this equation. X squared plus 2x plus 5 equals 0. Okay, right. Go ahead and solve this using the quadratic formula. Okay, I know I said I prefer factorising and completing the square, but there's a reason why I'm going to use the quadratic formula for this one. Okay, so solving is the quadratic formula. So x equals, and then you've got negative b plus minus square root of b squared, so it's 4, subtract 4ac, subtract 4 times 1 times 5, subtract 20, all over 2, and that's negative 2 plus minus square root of negative 16. Oh dear. Yeah, the root negative 16. And that's kind of in a nutshell why the b squared minus 4ac is one of the most important things of the quadratic formula. Okay? The fact we've got negative 16 under the square root means we cannot find a real solution. It does not mean we cannot find a solution. It does not mean it's impossible. It does not mean it can't be done. Okay? It just means you can't do it with real numbers. All right? If you want to do it, use complex numbers. Okay, but that's further maths. It's not A-level maths. Okay, it's further. So what we say is it's got no real solutions. Okay, so the first thing we'll write down is if b squared minus 4ac is less than 0, in other words, if the discriminant, if whatever we're square rooting is a negative value, okay, then there's no real solutions. Okay, I'm going to highlight the word real there. No real solutions, because you can do it using complex numbers. Further maths is where that comes up. All right. Yeah, so that couldn't be done. Right, let's try something else. Okay, let me give you another example. Okay, here's one. So I'm just making it nice and simple. Okay, so x squared plus 4x plus 4 equals 0. Again, use the quadratic formula to work it out. So you'd have x equals negative 4 plus minus square root of b squared, 16, subtract 4 times a times c, which is 16, all over 2a, and notice you end up with square root of 0, which is 0. Okay. So you end up with just negative 4 divided by 2, so it's 0. Okay. Unusually, you might think you end up with one solution. Okay, it's called a repeated root. Okay, why is it called repeated? Because you can factorise this. Okay, x plus 2 squared has x plus 2x plus 2, and look, you could say you've got two factors there, a repeated factor, x plus 2 squared. No, but the reason we call it repeated root is because generally we assign 2 roots for quadratic, okay? 3 roots for a cubic, 4 roots for a quartic, 5 roots for a quintic, 6 roots for a sec, and so on. Okay, so it's not really mathematically correct to say there's just one solution. Okay, it's called a repeated solution. Okay, because there are effectively 2 answers for quadratic. Okay, always 2 there are in a quadratic. Okay, a bit like the Sith. Okay, but a bit nicer than the Sith. Right. So the next one to write down is b squared minus 4ac is equal 0. Okay, and then we have I'm going to call one real root, and it's repeated. Okay. Forgive me if I'm using the word root for the first time. You've not heard it before. Root is another term for solution. Okay, it's where a graph crosses the x-axis. Okay, which is another reason why solving these is quite useful. Okay, and then you've got the standard one where you've got your, I say standard, so I meant to say the most common case is where you've got the discriminant is actually positive, and you end up with 2 different answers. Okay, and you have 2 distinct real roots. Okay, I'm putting brackets there. Distinct. Distinct means they are different. Okay, these are all mathematical terms I'm using. Okay, roots, solutions, repeated, distinct. Okay, and I won't give an example because you'd have solved plenty of those. Okay, so that's the discriminant. Okay, and that's why it's important. Okay, before we end the video, let's give you another example. Okay, Let's just think of one, just bear with me for a moment. So x squared plus 23x plus 132. You might think, oh wow, where's that come from? I'll go with this, okay. My question to ask you is, does this factorise? You either see it factorises, or you're like, not too sure. You can check by using discriminant if you want. B squared minus 4ac, okay. What you do is you square that, 23 squared, okay. I've gone and done it now, and I've given myself one that I don't know the square number of, okay. So let's see, 484. I know 22 squared is 484, so if I add on 22, I get 506, and if I add on 23, I get 529, okay, so it's 529. Subtract 4 times A times C, subtract 4 times 1 times that. What's 4 times that? 132, 264, 264, and then 528. 528, oh, well, that's simple. It just turns out to be 1, okay? Well, the whole point of that is if b squared minus 4ac turns out to be 1 integer in that case, it will factorise. Okay, maybe I shouldn't have given you such a silly one. Okay, maybe I could give you a much simpler one that you can do quickly in your head. Okay, check to see whether this one factorises. X squared plus 7x plus 12. So you do the b squared minus 4ac. So 7 squared is 49. Subtract 4 times. So I'm not doing this on purpose, but they're always, that. It's because the factorisation is like x plus 11, x plus 12, x plus 3, x plus 4. Well, I just try x plus 2, x plus 4. So x squared plus 6x plus 8. So then you've got b squared minus 4ac. So you've got 36. Subtract 4 times 8, subtract 32. Okay. There we go. 4. Okay. As long as I get the square number there, okay, then it will factorise very nicely. Okay. One way it doesn't factorise, like I'm just going to change that number to 7. I'm hoping you can see obviously it does not factorise. Okay. When you do b squared minus 4ac, you get 36, subtract 4 times 28. Okay, so that's going to be 36 subtract 28. It gives you 8. Not a square number. Okay. Because it's not a square number, then you can have the square root of 8. It will not be something that will factorise. Okay. So yeah, maybe you found that useful. Maybe you didn't. I don't know. But I just thought I'd shove that on the end of that.